of if we take a mixed if we take a mixed material, we're only going to get yield on the polyester. And that's why we have thresholds for the amount of polyester that actually needs to come into our feed streams for us to be able to take it. The good news there is that we have, very flexible policies. And our process on 100% polyester can get 95% yield, 99% yield, demonstrated many times. So that gives us some leeway to take in mixed materials and have something that we don't get yield on. Again, the objective of enzymatic recycling, and the reason I joined this company is that we will develop enzymes for all synthetic materials so that you give me a three synthetic material garments, and we will break down each one into its raw materials, leading to 100% yield. Obviously, that's idealistic and it's going to require a lot of time, but that's the real goal of enzymatic recycling.
Cool. So we were just down in the weeds talking about technical yields and processing and sort of very specific element of EPR. I want to bring it back up to sort of the higher level, sort of this notion of social license to operate. And, I think some of you mentioned that, plastics is sometimes seen as very controversial material. There's a lot of skepticism around plastic recycling in some cases, and just the recycling industry in general. So when we think about your social license to operate and to be a responsible participant in supply chains, what are you doing to try to create awareness around the good things that you're doing and the benefits you are providing, whether it's through community activities or sustainability reporting? So I just want to give you each an opportunity to kind of talk about how you try to educate consumers and others about the things that you're doing. So Nicole, if I can, I'd like to start with you around maybe, how do you position yourself as a responsible entity, not using the EPR term, but just more broadly?
Yeah, absolutely. Thanks, Laura. So ADS launched our ADS Foundation roughly 3 years ago, and it focuses, ironically, on the same 3 pillars our company focuses on: water, recycling, and community, right? Aligns right up with our business purpose. And so we've taken that partnership with the Nature Conservancy and the Recycling Partnership, as well as a number of other organizations to really make sure we're making an impact. And so the two I'm most excited about, I already mentioned, right? So the Recycling Partnership helps to increase equitable access to recycling. We selfishly partner with them. It makes business sense to partner with them, but on the flip side, it's also the right thing to do, right? Keeping materials out of landfill. So we work on that front. We also encourage all of our plants to be very active in their communities, right? And support those causes that have impact on conserving fresh water. A lot of times I'll see individual recycling activities going on at our facilities. And, to some extent, there's some of our plants that will take in, scrap material to directly recycle. So just, talking what we live, living what we talk every day, right? And vice versa. So making sure that we're all on the same page.
Great. Bob, can you talk a little bit about how you might be working in local communities, or more broadly, how you're educating stakeholders about advanced recycling?
Yeah, I really am excited to talk about the communities. So we're part of our communities. So we are in the communities, and the communities are incredibly important to us. For us to all succeed, we need to be, I think, harmonized around we want to improve our communities, and that's part of what our goal is. And so being present in ways other than just simply having a project or paying people is incredibly important to us. So we collaborate with communities as it relates to environmental initiatives. We do conservation projects, pollution reduction efforts, and we actually look at sustainable resource management. We support local education. In fact, we partnered with the Guy Harvey Foundation to teach a K-5 education around plastic pollution and then plastic solutions for the kiddos in a way that's engaging for the kids, and sort of turns them on to not as much the problem, but as problem solvers. Another example as well is in Indiana. We're located in Northeast Indiana, and there's the only school that really takes children, is able to support children with different disabilities is the Meadow Creek Elementary School. So we actually sponsor a recycling program that the kids all lead to separate the plastics from the lunchroom, and then we collect them and bring them out, spend time with the kids who are like the leaders there. And we're actually this summer here in August going to help the school. We help them with joint funding on a playground that's an inclusive playground, because many of the children in the existing playground didn't allow all of the kids to participate or in the school. So it's incredibly important to us. We do a lot of other things as well, but you can tell the feel for us is about improving the environment, and that extends to the environment even more broadly in the communities where we're present.
Right. So Francesco, I want to bring this to you. I'm not going to ask you about community engagement because you're not really at that stage yet in your organization, but you have a very unique process. Enzymatic recycling, I think, is new to probably many people on this call, and it's clearly emerging technology. So can you talk a little bit about how you even explain that to people? And then I've got a follow-up question that's going to sort of link the three of you together. But maybe just start with how do you even tell people what the heck you're doing?
So it definitely depends on the interlocutor. I think the simple way to do it for the audience here is to say, chemical recycling, but our catalyst is an enzyme and we operate at low pressures and temperatures. That usually sets the stage for the conversation. If we have to go a step back, enzymes are molecular scissors that break things apart and they catalyze reactions. We have so many in our bodies, and everything we use on a day-to-day basis, we engineer those to do something that we want, which is break down plastics, specifically polyesters. So imagine these, nature's smallest machines breaking down things that we want. Well, doing things that we want to do, right? Enzymes are catalysts at the end of the day. They're sequences of amino acids. At the end of the day, very simple. Engineering them to do something specific is very difficult, and our team has been very focused on that. So that's usually how I describe it.
Yeah. Okay. Well, I'm going to start turning towards more audience questions. We've addressed some of them, and I've seen some of them have been addressed through the chat. Excuse me. But one of the questions that I thought was interesting was a question for you, Francesco, around once you have an enzyme that has sort of attacked a garment or a carpet or whatever you might be working on, and you have these leftover products. Are you looking for other recycling technologies to sort of take those byproducts? And could you envision somebody like ADS or Brightmark taking your byproducts as feedstocks for their technologies?
Yeah, so that's something I'm working on right now. Actually, it's a fairly novel initiative, but figuring out, if we have blended materials, we can take the stuff that we cannot process. And that's definitely a conversation I'm open to having. The materials that we see most commonly with polyester are obviously natural fibers. So cottons, I don't think Bob and Nicole can process those right now, but perhaps. And then there's a lot of cotton recyclers out there. So that's something that we're organizing sort of trials with them to figure out best practices. And then in terms of synthetic materials, it's, nylon, elastane, spandex, which is polyurethanes and polyamides. Those, there haven't been that many solutions for recycling them, hence, why we're focusing on them now as well on enzymes, but definitely that's the goal, right? To have sort of a consortium to take these textiles.
Yeah. Nicole, can you build on that? I mean, do you work with other industry partners to take, if you get materials in and you have materials that you can't process or you don't want to process, are you working with other recyclers to take those materials from you?
So absolutely. If you look at diversion rates across our plants, our recycling plants have the lowest diversion from landfill, and we're working to make that better, right? Because especially where we're bringing in post-consumer material, we're very picky. Our stream has to be very clean. So if we're not bringing in A quality bales, we have a lot of side streams that need to be processed by someone else, right? So we're doing secondary sorts. We're even looking at byproducts of the recycling process and finding new homes for those as well, right? Making sure that we can get as much of the material that's going out of that plant back into a product. And our procurement team has been super active in really seeking out those opportunities and looking for innovative ways to reuse those materials, right? Kind of thinking outside of the box and just reaching out wherever they can and making those connections so that we can do that. It's not easy, right? If you want to click the easy button, circularity is not easy. And I remember, the first time I heard that term 20 years ago as a chemical engineer, my mind kind of spun for a little bit, right? Because we had been doing take, make, waste for so long. But then I got to thinking about it, and I'm like, you can't get to circularity without biology and chemistry, right? I mean, and we're talking about that today. You can do so much with mechanical recycling, but without chemical recycling and biological recycling, you can't get entirely there. So, it's everything has to work together, and I think that's what we've kind of demonstrated today, right? That these three technologies all have to work together.
Yep. So I'm looking at the questions from the audience, and there's a cluster of questions that came in around sort of challenging materials. And so I'm going to sort of pose this as a high-level question and ask you to pick one or both, but thinking about topics like microplastics and also things like potentially harmful substances, whether it's heavy metals or PFAS, sort of forever chemical type of categories. So Francesca, why don't I start with you? Like, does your system tolerate those materials? Does it actually separate those materials? Are you thinking about microplastics and or some of these other challenging chemical substances and how they affect your system?
Absolutely. So we have, very stringent filtration systems to take out anything that we don't need, and then post depolymerization, we remove everything we don't want. Now, I think the topic of microplastics is very interesting because it's become a huge focus recently. And the plastics we produce, right, are at the end of the day plastics, and there is going to be inherently a little bit of shedding. Now, it's become very popular in the media, I think, to talk about microplastics as something that comes out of plastic. That's why people should move towards glass and towards aluminum containers, et cetera, when they forget that plastic often, plastic containers have a lower carbon footprint than aluminum and glass containers when you take into account the weight, the shipping, et cetera. And so I think the microplastics argument, I'm very eager to see how it develops because the research is still, I'd say, somewhat limited on the topic. We take it out, right? That's not something that affects our processing, but then our outputs, right? Inherently, because we are making plastic, that is something that is top of mind. How do we make non-shedding plastic, right? Does that even exist? Is that a possibility? I'd love to learn more about that essentially, and I'm curious.
Yep. And Bob, same question to you, like, does your process tolerate these impurities? What happens to them in your outputs? And can you talk a little bit about either metals, microplastics, or things like PFAS?
Sure. Yeah, so our process has to tolerate materials like PFAS materials and other contaminants. And the reason why is because they're present in plastics. A lot of the additives to plastics materials, there's a variety of different types of plastics, right? Not just the food application plastics we use. Those types of materials and chemicals are present. So we have to be able to take that. Further, our process and how we take the liquids once they're produced out of our process, on site, we reduce PFAS and other contaminants via the use of well-known technology called hydrotreating. And while we can't reduce to zero, we greatly knock out those materials. We continue to do work on exactly how much. So we are concerned about that. And I think that this is part of where looking toward the products that we add to plastics should be a focus area so that any PFAS types of materials that we're concerned about really in the manufacture of new plastics are, hopefully eliminated or greatly reduced. So because we're environmentally focused, not about perpetuating just plastics or any other thing, it concerns us. So as it relates to microplastics, another area of concern, and Francesco, I take your comments 100%. I think in addition to not fully eliminating, but one of the ways to greatly eliminate microplastics getting in the environment is to reduce waste plastics that are in the environment by the processes that the three of us and others are working on. So if we reduce the amount of plastics that hit rivers, waterways, other ways of getting into the environment, you'll reduce the impact. But with some textiles, obviously, when you wash clothes, to the extent there are plastic fibers in there, those are going to be in the water stream. So other things like filtration, et cetera, pulling those out, I think are areas that we should focus in on too. But by reducing dramatically waste in the environment, I think we aid microplastics greatly.
Great. Bob, I want to stick with you. There's a couple of questions here about some materials that we haven't talked about at all, sort of some unique and challenging streams that some of our listeners have to deal with. One of them is mattress foam. Have you ever dealt with mattress foam? And the other one is, would your technology be able to process tires? My recollection is that there has been a lot of pyrolysis of tires, but I don't know if you can take that as a feedstock or if that's really a separate type of pyrolysis.
So on the last one, the tires, we can take tires. I think the waste problem isn't necessarily about whether or not pyrolysis, our class of technology, our specific application can take it or not, because we can. If you look at tires, there are different fibers, oftentimes in the bead and in the tread itself. So for us to be able to utilize tires, we would need to break the tires down. We need to pull the beads out, and then we can certainly take it, but a high proportion of metals laced into the tire composition material. It can be done. It will come out as a waste product, the metals out of our process. So we can do it. But the biggest part is, how do we chunk it up and eliminate as much as possible of the non-plastic material? So it's possible, but the greatest challenge is, what do we do with the tire that sits there with the bead and the things in the tread? So we could do it if we took just the beads out and chunked into small pieces. But that does introduce a greater amount of metals, which would come out of our process.
Yep. And I don't know what mattress foam is made out of. There's probably different foams used in mattresses. I don't know if you've ever looked at mattresses as a source, and either Francesco or Nicole, by nodding or shaking, either of you working on mattresses? No.
Yeah, I can confirm. Go ahead, please. Francesco, go ahead.
You're the expert here. I'd say we are going to be working on them soon. We have a shipment coming, but haven't done anything too deep right now.
Yeah, I would say that's a future area for us. We can certainly take the foams from the mattresses. There are recovery opportunities there, I would expect, but that's just not been a focus area yet. And I want us to ultimately take care of all of these plastics. And so that would be one example of ones that we got to get to. We're not there yet, right? Another one I would add to it is, while we can take medical plastics that are, sort of industrial streams, the actually spent medical plastic products, there's work that needs to be done so that in a facility like ours, we can take, obviously, issues being the biological materials. And if you can think of one of the most necessary uses of plastics, if in fact the most necessary use, plastics in the medical environment would be probably the greatest in my mind. So there's opportunities with new classes of plastics that have been used that we must get to and solve.
Yep. There's a couple of comments in the chat box that have conveyed, and thank you for the audience participation here, that it seems like a lot of this mattress foam is urethanes. So Francesco, you mentioned that you're going to be looking at enzymes for urethanes, and maybe some latex in there too. So clearly the world has a lot of different forms of plastics, and we often think about our packaging plastics and all the work these companies do on sort of the traditional 1 through 6s that we can identify. And then we've got that giant category of the 7s, which is kind of everything else under the sun. As Bob mentioned, medical waste, urethanes, textile waste. There's a lot of other stuff out there that doesn't come into our recycling bins at home. But clearly, through these complementing technologies, we can do more than just the common packaging grades by offering different technologies. So fun to see. We're down to the last few minutes here. Megan, I don't know if you have any closing remarks. I think we probably have a couple more questions, or maybe 1 or 2 more that we could address here. Nobody has touched on the subject of food grade. Nicole, that's probably not a space that you're interested in just based on your markets, but Francesco, has that ever come up in your process? As your output, would it be eligible for food contact after you've processed it?
Yeah, so that's a whole process that we're going to be looking really deeply into once we start producing in large quantities. Right now, our scale is too small for us to spend time too deeply on the certifications there. But it is, it's a process that you just have to do.
Yep. And Bob, I think a lot of people, that's one of the advantages that people tend to refer to when they're thinking about advanced recycling is once you get those monomers back down, they're essentially the same quality as virgin. So could you comment on food grade?
Yeah, I mean, I think you just said it there. It's indistinguishable from, ground extracted, fossil extracted hydrocarbon material. And so, yes, we can make all forms of plastics, including food grade plastics as well. So, yeah, it's one of the great opportunities here because food grade plastics, it's challenging with other different types of recycling type technologies to get there.
Great. I think we've covered a lot of these topics. Megan, do you want to jump in if there's a topic that I didn't touch on from scanning the questions that you want to make sure we address, or just wrap it up here with a couple minutes to go?
Yeah, no, I think we can wrap it up. I think we touched on the majority of the questions. So thank you, audience members, for your engagement. And Nicole, Bob, Francesco, I'm sure you're willing to, make yourself or your teams available to people if they have additional questions following the event. Yeah, so, and we actually are in the middle of planning a webinar that will touch on hospital and biopharmaceutical solutions for single-use plastic. So, maybe connections to come there. Looks like we have a few more questions coming in. So, but thank you so much for our speakers. Thank you, Laura, for moderating. This was very insightful discussion, and I think a lot of great ideas came out of it. We have a lot to tackle as an industry and society around this. So thank you again. And I also want to thank you, Nespresso, as well, for sponsoring this event again. So we will be sending out the presentations as well as the recording following the event. And I hope everyone has a wonderful rest of your afternoon. Thank you.
Thanks, everybody.
Great to be here.